Let me get into my AWS account. Today we're going to discuss the important aspects of AWS. That's some core concepts like Amazon VPC and Amazon S3 and Glacier. And we're going to discuss about auto scaling, Amazon CloudWatch, and Amazon DNS and Route 53 and few things I'm going to discuss about identity access management. So let me start with Amazon VPC. What is VPC and how to manage VPC? And we're going to learn about how AWS implemented VPC in their public network. And then we'll be discussing about Amazon S3, and Amazon Glacier. And after today's session, I'm going to discuss about Elastic Load Balancer and auto scaling. And fourth one, I will discuss about identity and access management and Amazon Route 53. So, and this is the agenda. And the end of the session, I will be discussing with you about AWS examination. So that will be that we have separate session, and we are going to discuss about that stuff also. So let me start first of all from AWS VPC. See, you guys has been maybe got a huge amount of talent about Amazon VPC and huge amount of information maybe with you in hands-on. When we talk about Amazon VPC, this is a wonderful console that we can able to we can able to manage and maintain all the networks-based stuffs here Amazon VPC. See, so far in our previous Zeedup Marathon sessions, we have seen about EC2 and its features and its uses, how we can deploy scalable and fault-tolerant application using it. I can say that EC2, this one, Elastic Compute Cloud, comes with its own set of some little bit drawbacks. So for basic users, I can say that because you do not have control the IP address of your instance, something we're launching instance in VPC, that you cannot have total control of IP address of your instance, apart from adding Elastic IP that I discussed yesterday. So by design, each of your instances in AWS, I can say they will get a single private and public IP address, which is routable on internet. Again, something you cannot control, right? So suppose I'm launching an instance, my AWS will give a public IP, a private IP for the specific instance that you cannot control by yourself. Can you able to control the instance IP address and those public IP, private IP yourself? Absolutely not. So that's why this is important to understand about the importance of creating your own VPC. Now I'm not creating my own VPC. I'm going to launch an instance via default VPC. So what is the basic structure for default VPC that I told in this networking infrastructure was not in your control. This is something it is control in AWS. So let me suppose so I'm launching one instance, and after launching an instance, you can see that anything is your control? No, the private IP automatically given and public IP automatically given, everything given by that. And also I can say that because each instance belongs to specific security groups, here we have specific security groups, and I can say EC2 security groups have the capability to add rules for inbound traffic only, and there is no support for providing any outbound traffic rules that I already told that in Amazon EC2, because we have something called security groups, the inbound outbound traffic. So also this EC2 is good for hosting your application, and I can say it is still that secure. That's a question. When you're hosting application in Amazon EC2, it is still that secure. Sometimes answer is not. So who will make secure? Who will make more secure about what are the application you're hosting Amazon EC2? The answer for all those types of problem is Amazon VPC. The Amazon VPC is the one who got the, this is the major answer for all the problems that we are getting in Amazon EC2. So that's why I came here to today explain about Amazon VPC, because Amazon VPC, what is Amazon VPC? I can say it's a logically isolated part of AWS cloud that enables you to build and use your own logical subnets and networks. In simple terms, I can say you get to build your own network topology and you can spin up instances within it. But what actually separates VPC from your we have two types of things we have. We have EC2 Classic and EC2 VPC. So the question is, what's difference between that will take that separate you from EC2 Classic environment and EC2 VPC? I can say that now after 2013, Amazon Web Services has released a separate major console, so something called EC2 VPC, where you can choose which instance are accessible over internet and which are not. So you can create bunch of different subnets within a single VPC, each with their own security policies and routing rules. See VPC, you can see this is a VPC screen, and you can see here VPC provide added layer of protection by enforcing something called network access control list. Because network access control list, besides your standard use of security groups, this ensure that you have total control over, I can say, what traffic is routed in and out of your subnets and VPC as well. So that is why this Amazon Virtual Private Cloud is so important to understand, because it gives total security, total control, and the total network. You can keep everything at your fingertips. So that's why VPC also provided added functionality using which you can connect and you can extend your on-premises data centers to the AWS cloud. This achieves using IP security policy and something called VPN tunnel, and that connects from your on-premises data center gateway and to something called virtual private gateway. So it's called VPG. So this is a VPN connection. So all those stuff is going on here. And the basic structure of Amazon VPC goes something like this. Suppose because I have AWS, and inside AWS we have VPC, and inside VPC we have EC2 instances. So that we are launching inside VPC EC2 instances that communicate with the router, that is a software router, and the router will communicate with VPG, virtual private group, and then he will communicate with the customer gateway. So this is the one, and it's connected with corporate network. So like this, it will go. So all this EC2 instance comes under specific availability zone, and via that availability zone, they communicate with router communicate with your private gateway, and then your private gateway will communicate with customer gateway. So like this, it goes something like this. So here you can see there's important point to note here that VPC is still part of AWS cloud. Maybe you create a private cloud, or maybe create a public cloud. VPC is still part of the AWS cloud, and it's not physically separated hosting provided by AWS. It simply is a logically isolated part of EC2 infrastructure, and this isolation is done at what layer of OSI model? It's done at network layer of OSI model, and it's very similar to traditional data center network isolation. It's just as the end users are shielded from the complexities of it. Okay, let I show you one demonstration how to create your own VPC and launch an instance. Here, when you start this one, so create your own VPC and select it. Here you can see this is called this is a CIDR, that's called classless inter-domain routing, and each subnet that I'm creating has 65,531 IP addresses free for me. And because each and everything is important to understand, that here in the services, like what is subnets, what is route tables, and what is internet gateways, and what is NAT instance, what is NAT gateway, everything is important to understand, because this really gives us what is a complete understanding of how VPC works. In case of I'm creating one more network and give VPC name AWS VPC, and subnet name I'm going to give this private subnet, and I can select which availability zone I want it. So let me no preferences. See, just remember Amazon Web Services. So I'm in this United States, North Virginia region. So it consists of 6 availability zones. So this means AWS has 6 subnets that is created and kept for all the 6 availability zone, and each availability zone has got 4091 IP addresses are free. I will show you that later. Okay, so let use endpoint. So endpoints are very effective one. I am going to add endpoints. So I have full access. So okay, let me have this one. Okay. So this is an endpoint that AWS gives us, and you can add tenancy, create VPC, and just so now create VPC. Now you can see it's going to create my VPC with the subnet of 10.0.0.0/60. Okay. Now you can see this is connected, and this is my default VPC is connected, and this is the VPC that I created right now. When go to subnets, here you can see this is a private subnet, and you can see this is I have 251 IP addresses free. So as I told, in United States North Virginia region, I got 6 availability zones. You can see each and every availability zone has got 4091 IP addresses free. First of all, you need to understand what is meant by subnets, okay? Because this is the basic concepts of VPC and those terminologies. Because you should have depth understanding of VPC, because VPC is nothing more than is network service provided by AWS, which you can create logical isolated environments for your EC2 instances. And just like any other network services, VPC too works on some key concepts like subnets. Okay, as I told, see, perhaps the most important part of VPC is that the subnet are nothing more than the range of valid IP address that you specify, that I specify right here, like this. So VPC provides you with 2 different subnets creation option. One is I can say public, and that is called public subnet, and second one is called private subnet. So what is mean by that? Public subnet, and next one is a private subnet. So that's something you have to understand, because I can say that there are 2 types of subnets: are public subnets and private subnets, and how this process works. See, suppose you're launching an instance in either of these subnets, any of these subnets, depending on whether you wish your instances to be routed on internet or not. Now the thing is, when you create first VPC, like I created, when you first create a VPC, we provide a set of IP address in the form of CADR. So I given CADR/24, right? So /24 means suppose I'm giving this IP. Let me give, suppose I'm giving 10.0.0.0/16. So /16 indicates that this particular VPC can support up to 65,536 IP addresses. So 65,536 of IP addresses, and that's something called 2 power of 32 minus 16. Okay, and 65,536 IP address can range from, what is the range from, go 10.0.0.0 to it go to 10.0.255 or 255. It goes something like this. So once the VPC CADR block is created, you can go ahead and you can create your individual subnets from it, and you can able to launch the instance inside that. So as here you can see, now I'm going to subnets. You can come here. When I click on this one, it is subnet actions, and go to internet gateways. I'll be talking about more on internet gateway short while. So when we create the subnets, you can see this is the one I created. This is this you can see one subnet, and I can attach set as a main table. Okay, so, but it is not set as a main table. So I can go there and I can select and I can set as a main table, or I can again, this is my default VPC. And moreover, see the basic idea behind this 65,535 IP address is that, because suppose you have created 2 subnets, each supporting 256 IP address. So suppose you're going to give this address. Suppose you're going to 10.0.0/24. This includes 256 IP addresses. Like when you go here, you can see 251. See why I told 251 and I told 256, right? What happened to other address? Because AWS will reserve uh, first four addresses for internal networking purposes and last one addresses for internal networking purpose. So that's why so 251 IP addresses, two available addresses are there, and remaining addresses are reserved for internal networking purposes. Now, see, now you can specify the subnets for web server as a public, and they need to be routed to internet, and subnet for database and servers to be private. They need to isolate it from outside world like this. Like this, you can able to split this one. Then come to route table, you can see this is attached with local, and well, so that's why this is important to understand about the sub, because now you understand that default subnet for all availability zone in AWS is start from /20, and /20 is the default subnet that AWS has given for all those what is inside regions and availability zones, and default VPC supports /20 CADR. They start from 172.31 IP addresses. There are one additional thing that you have to understand. By default, AWS will create a VPC for you in the particular region for first time you sign up for the service. As I told, that's a default VPC. Right, the default VPC has some restrictions. You know, in many interviews they're asking what are the restrictions we have in default VPC. So the first restriction for the default VPC is that when I go to default VPC, so by default, I can say this default VPC has got some restrictions. I can say default because first is default VPC is always created with CADR block of /16, and which means it supports 65,536 IP addresses. The next one is the default subnet is created in each availability zone of your region selected, right? There is a default subnet is running. Okay, I told that this is a default subnet. Apart from this is a default subnet running in the specific availability zone of the region, and instances launched in these default subnets have both public and private IP address by default as well. And next one is an internet gateway is provided for default VPC to the default VPC, for instance, to have internet connectivity. And talk about internet gateway. I will be coming back on here. And next one is next restriction, next concept is for default VPCs that I can say because a few necessary route tables, it is automatically created like route tables, security groups, access control list, and they are also created by default. These all things created by default. One ACL is there, and one route table is already associated. And these all things by default AWS will create as the name of default VPCs that enable the instant traffic to pass to the internet. And that's why. So these settings are already predefined. We have. So this means you can use this default VPC as just any other VPC by creating additional subnet in it that provisioning route tables, security groups, and so on. In fact, the instances that's because all the instances now in AWS are based on default VPC, and we have to understand two things: that any other VPC that is something called non-default VPC that you're going to create, right? Any other VPC that you're creating besides default VPC is called non-default VPC, and each non-default VPC term contains non-default subnets and like this. So I have created non-default VPC here. This is a private. This is a non-default VPC, and this is not comes under a default VPC network. So, for example, suppose I'm going for EC2, I'm going to launch an instance. For example, so here, suppose I'm launching one instance here and selecting, and now you can see my created one VPC will show here. So I can select that VPC, and it has 251 IP addresses available, and this is called private subnet. So let me launch an instance inside that. So I have launched instance with my own created VPC. Yeah, you can see I got some IP.10.0.24, and since I have not asked any public IP, so obviously I go for elastic IP to launch this particular instance. So, and this is how the subnet, and moreover, we need to understand more depth of that. So first of all, in this Amazon VPC, we have different things to understand. The first thing is it is something, it's very open network, okay? Because when come to because Amazon VPC, it's a networking layer for Amazon EC2. Okay, so most of the time we are using Amazon VPC for network layer for Amazon EC2, and it allows you to build your own virtual network within AWS, and you can control various aspects of your Amazon VPC, selecting your own IP address range, creating your own subnets, configuring your own route tables, network gateways, security settings within a region, and you can create multiple Amazon VPC, and each Amazon VPC is logically isolated, and if it is shared, its IP address space. So I'm talking about these networks or something. It is logical network. Okay, so this is a logical network that what we have in Amazon EC2. So that's why, as I told, that when I go to services, you can see that this got one IP, and I'm going to Elastic IP. I'm going to associate the address with them, and here you can see the private VPC, and I'm going to attach that address with them. So I got attached, and now you can see, now when I go to instances, so here you can see I got an Elastic IP for that, and this is my private IP. So you can launch more instances inside the private IP, the private VPC, or the private subnet that you have created. So as I told that and just remember, as I told, the default network for launching instance inside AWS is starting from this 172.31.0.0/16. This is the default, because default VPC created in each region with the default subnets created in each availability zone, and this assigned CADR block of VPC will be this. And we have, so that's why suppose you have created three VPCs, okay, say two VPCs, okay. So suppose I have given 10.0.0.5 and 1 and 10.0.0.6, and suppose I have given 10.0.0.7, and this all comes under subnet 1. So subnet 1, what is subnet 1? It's come to 10.0.0.0/24, and it's running in one availability zone. So this means that we have two availability zone and two availability zone running separate subnet, and two availability zone cannot connect to each other. So in order to communicate with two availability zone, we need to have a route table. The route table will integrate with those things. So this is subnet 1. So let me go to subnet 2. Subnet have 10.0.1.5, 10.0.1.6, 10.0.1.7, like this. So what is subnet? This is comes under subnet of just say 10.0.1.0 and comes under /24. So this will run one availability zone 1, and this subnet will run in availability zone 2. So this is separate and this is separate, and that's why. So these two networks will be running in VPC, and to integrate these two subnets, this subnet 1 and subnet 2. This is subnet 2. So we need to have a route table. So there is a router that's running between this subnet 1 and subnet 2, and they're going to communicate with each other. So this is the basic idea of what we have in Amazon VPC. So you can create n number of subnets here in VPC, and you can integrate with those things. And you can see you can create another VPC, and so the default, as I told, is CADR value is 16. That might be 20, and create VPC, and here we can create 20 and VPC AWS 1. So again, you can see I have created second VPC, and this also a private VPC. So yes, so you can see when I go to this one, and you can see the VPC, and this one, two VPCs separated, and one is 10, one is 20. I go to route tables, you can see with the subnets, you can see 250 and 251 APIs are available. So yeah, so this is the public subnet, and this is also a private subnet, but name given as a public subnet. So let me do this. So, so this you can see this private subnet 0 and private subnet 1. So this means you can able to integrate these two things by adding ICMP as a security is ICMP protocol. The traffic should be allowed for those are the instance you are launching in the specific subnets, and you can allow ICMP protocol inside the security groups, and you can able to communicate with those things. And see, Amazon VPC have different concepts like subnets, route tables, DHCP, option sets, and then they have security groups, network ACL, then elastic IP, ENI, elastic network interfaces, and then endpoints, and then peering, NAT gateway, NAT instances, and VPG, virtual private group, the customer gateway, VPN, virtual private network. So these all things we have here, and this is a big network, okay, where you can able to segregate your network into different availability zones, and based on that. Many questions asked here. What is mean by this network ACL and network security groups? I can see we have talked a lot about about the security groups in past AWS Marathon old previous classes. We do know that security groups are nothing but just it's a simple firewall rules that you can configure to safeguard your instances. And you can see by default you can create maximum of 100 security groups for a single VPC, with these security groups containing 50 firewall rules inside them. And also, it is very important to remember the security group does not permit inbound traffic by default, and you have explicitly set inbound traffic rules and allow traffic to flow on your instances. And so, however, all outbound traffic from the instance are allowed by default. This is something called that happens in security. When it comes to network ACL is something new because this provides added security measures over security groups as they are instance specific, whereas network ACL or subnet specific. Unlike we having security groups, however, we can say this both security network ACL security groups and both are allowing and restricting inbound and outbound traffic using ACL rules, access control lists. Because speaking of ACL rules, they are much familiar to this network ACL much familiar like security groups. But however, one exception is that what exception, each ACL, okay, each ACL rule is evaluated by, I can say based on that number, and the number can be anything from 100 way to 32,766, and that's why. So this is the maximum ACL that we can resolve it. And that's why I can say that the ACL rules are evaluated in sequence, starting from smallest number and going all the way up to maximum value. Okay. See, we have seen, suppose you have knowledge of Cisco routers or Juniper routers or Barcoda firewall, or maybe FortiGate, any type of this firewall. So they have some ACL, network access control registers, where they will be checking strictly for the packets that have inbound outbound routes. If the packet is matching the rules, then he will allow to go out and come inside. If it's not allowing, then it is blocked. There's something we have, but compared to security groups, ACLs are most strict, and ACL are best in the industry to protect the information. And that's why. So we have different types of, because we have ACL, we can create network ACL here, and with what VPC I have. Because see, ACL rules are created by AWS for your default VPC. You can see. For our default VPC, this ACL rules are already created. This particular ACL is something called default network ACL as well. The question is, what do these rules mean? So for starters, okay, for freshers, you can say, as I told, suppose the rule number 100 for both inbound outbound ACL specifies the traffic to flow from any protocol running any port in or out subnet. And you can see that we have inbound rule. You can see there is an asterisk, right? What do you mean by that? The asterisk is also considered as a rule number, and it must be in all ACL. And it basically means that you drop any packet that do not match ACL values, and it will be checking out ACL and security groups. So that is why ACL is the one which is far more better security than security groups. And also, example, we can have 100, so he can able to match 100 rules. So that's why ACL network. So you have to understand the difference between network ACL and security groups. Okay, when come to route tables, what is this route table? Actually, You see, route tables are pretty straightforward and easy to implement in VPC. And I can say that I can when I select any which one I can set as a main table. See they are nothing. This is route tables are nothing but simple rules or routes that are used to direct network traffic from the subnet. And each subnet in a VPC has to be associated with single route table at any given time. But however, you can attach multiple subnets to the single route table as well. Okay, just remember default VPC and default subnets. There is a two types of things. We have default VPC, have default subnets, and well, as it see similar default route table is also created when we first start our VPC. There is a default route table. There is a default how we have default subnet, default VPC. There is a default subnet also, and this default route table is called as a main route table. Okay, so I can set any of the route as a main route table, and generally contains only one route information that enables traffic to flow within VPC itself. And subnet that are not assigned to any route tables are automatically allocated to the main route table. And see, you can edit, you can do something, you can delete, and you can set as a main route table. You can create a route table. And however, see, just remember, you cannot modify the local route. Many people say that you cannot modify because the local route is as you can see, that is a best fit. And as you can see that there are a lot of tables are here, right? There are a lot of tables. I can say that here you can see we have local route table. That rules called it goes for 10.0.0.16. The second route table, something called AWS1 and the AWS VPC. So there's a combination of private connection made between VPC and other AWS services. So that is why these route tables are important, and we can use it. When come to VPC endpoints, this is also very important to understand about what is this endpoint, because see, you can able to you can able to pull up S3 bucket information by having the endpoints. I can say because VPC endpoints basically allow you to securely connect your VPC with other AWS services. These all virtual devices. I can say this endpoint is called virtual devices that are highly available and fault tolerant by design, and they are scaled and managed by AWS itself. So you don't have to worry about the problem of maintaining them. So all you need is to create a VPC endpoint connection between your VPC and AWS services of your choice. And so your instances can now communicate securely with other AWS services, and the instances in the VPC communication with other services using their private IP address itself. So there is no need to route the traffic over the internet. That's why we are using the endpoints, and you can select which VPC you want, AWS one, and select the services. That is a DNS at IKC, and this is created, and I can able to have this private subnet and create an endpoint. So I got successfully created an endpoint for that. See, that's why after a few times the endpoint will be added here. So now just remember that AWS currently only support VPC endpoint connections for Amazon S3. Okay, many people say the endpoint will be created for other than Amazon S3. No, it is created for Amazon S3. So when these endpoints are created, it will create when you first need to select either VPC route table. Here is created, either you create VPC route table, and the traffic between your VPC instance and AWS services will be routed using this particular route table, similarly to any other route information. And VPC endpoint also contains the destination field. So you can VPC ID, right? And I can say that contains AWS service prefix list ID, which is generally represent the following some ID name, and we have this, and also we have a target. Right, so because that is called VPC endpoint ID, which represents. So via this ID we can, and endpoints also provides additional feature using which you can control and you can access to the remote AWS services. This is achieved using something called endpoint policies. So there is an endpoint policy associated with every endpoint VPC here, and that's the thing. It's important to that we have to understand, and it will return one statement. Right here you can see when I go to select a services, it can return they created this is endpoint policy, and that is there here, and this is how you just create endpoints. So moreover, endpoints are very interesting concepts when come to understand depth of that. Let me go to internet gateways. So what is mean by internet gateway? So that's the important thing to understand, because you maybe break your head on this. I think you know about NAT, like Network Address Translator. See, Internet Gateway, as the name suggests, okay. So you can, so I need to deattach from VPC or attach from VPC. So Internet Gateway name suggests this is a primarily tool used to provide internet connectivity to your VPC instances. All you have to do is to create and attach the Internet Gateway device to your VPC and add a route entry in your public subnet route table to point to the Internet Gateway. I can see here. As I told, the default VPC comes with Internet Gateway already deployed in it. So any instance that you launch from the default subnets obtains Internet connectivity automatically. Suppose I'm launching one instance by a default VPC, that instance will get Internet connected automatically. This does not apply for non-default VPC, right? So, however, an instance launched in a non-default subnet does not receive a public IP address by default. So, you would have to either assign one of the instances during the launch phase or modify your non-default subnet public IP attributes, or you run behind Elastic IP. So, once you have created and attached Internet Gateway to your VPC, that's why it is already attached. Okay, you can deattach also. So once you attached your gateway to VPC, you will also have make sure that public subnet route table has an entry for this gateway. Plus, also you have to create and correct set of security groups and network ACL rules for all of the subnet traffic to flow through the internet. That is why, for this purpose, we are using an Internet Gateway. And because Internet Gateway is going to resolve the IP addresses, so that's for private IP and public IP. So besides the internet connectivity, Internet gateways also perform NAT, as I told, on instances private IP, and instances in a subnets are only aware of their private IP address that they use to communicate internally. And this Internet gateway maps the instance private IP with an associated public or elastic IP, and then routes traffic outside the subnet to the internet. And controversially, the Internet gateway also map inbound traffic from the internet to the public or elastic IP and then translate it to the instance private IP address. This is how your instance receives internet from within a VPC, which brings us a lot of another interesting concept we have along with Internet Gateway. There's something called NAT instances. So many questions you have asked about that NAT instances. I can say that we have NAT gateways and also the NAT instances. What is mean by that? See, actually, if you understand, because in private data center, there is a lot of things is going on like NAT, or maybe I can say NAT gateway, NAT instances, network address translator, port address translator, static NAT, dynamic NAT, all those kinds of stuffs. See here, NAT. Okay, we have NAT instance. See, NAT. You know that it is a process that used to convert public IP to private and private IP to public, and that's why. So the now question is, what about instances they are in private subnet? How they communicate with internet without having direct internet connectivity via the gateway? And that's why where the NAT comes into play. And NAT instance is a special instance created inside your public subnet that NAT that's outbound traffic used to NAT outbound traffic from instance based on your private subnet to the internet. And it is important to note that here that NAT instance is only forward outbound traffic and not allow any traffic from internet to reach the private subnet. Similarly, this is one-way traffic, I can say. And that's why I can select any subnet here and I can allocate an elastic IP. So when you create a NAT instance out of any AMI template, AWS provides a few standard Linux-based AMI. They are well suited for such purposes. And this AMI are listed in community AMI page, where when I go to technique rotate here, yeah, this is there. So when I'm talking about when I go to EC2s, we have something called community AMI, right? So when I go to launch instance, and then we have community AMI, yes, this one. And that's why I told these are the special AMI are listed out as a community AMI page, and you need to filter it. Filter out the AMZ AMI VPC NAT. There's something written there. Okay, so from the drop down list of that. Okay, so because the AMI has some names right here, and some instances AWS has given this name AMZM. So I write here. This one AMZM, and it will be written as AMI, and VPC, and this is a NAT. If you see these types of names, and you can understand that this NAT instance, okay, that you're creating NAT instance, and I can say that few Linux-based instances will get these types of AMI ID, or that's because we need to find it there. We need to find it here. Which one have that ID here? We need to find it, and we need to segregate. We need to filter it on inside this. So this is so what I'm coming to say that NAT instance we have out of AMI, and AWS provides a few standard Linux-based AMI that well suited for such purposes, and that's why those AMIs. And one of them I can see here. This is one of those types of instances. This AMI. I can say that AMI Linux, and this is also supports NAT instance by default automatically. And when we see the NAT instance and the public subnet and private subnet, and my EC2 instance will communicate with my NAT instance, and via NAT instance I'm going to communicate with my router, and via router I'm going to communicate with the internet gateway, and via internet gateway I'm going to access the internet connection. So this is how it works between the NAT instances and between my instances. Let me go back here. Yeah, so that's why this is VPC, and if we talk about more about that VPC, so because we have something called DHCP option set, DNS and DHCP option sets, because VPC provides an additional feature called DHCP option sets, using which you can set and customize DNS and DHCP for your instance. And here you can see, and the default VPC comes with a default DHCP option set. Here you can see is that used to provide instances with dynamic private IP address and resolvable host name. What do you mean by that? You see, using a DHCP option set, we have inside this we have a DNS. You can see everything provided by Amazon. See everything provided by Amazon. And suppose I'm launching on subnets. Okay, so Amazon DNS server is provided in our VPC and runs on reserve IP addresses. And for example, suppose I have subnets of this 10.0.16. Suppose I have this subnet 16, then Amazon DNS server will probably run on 10.0.0.2, and you can additionally and I can see you can additionally provide an Amazon DNS server IP that come from 169.254, 169.253. And if you don't want to provide yours, so just leave it. Amazon provide DNS as required. So AWS, what we do, so the value that you have entered automatically added to Linux instance by this file. That's something called, you know that this is a resolvable file called etc. Then the resolve.conf. This file needs to resolve the name resolution. For that, that's why if I'm going to instances, all instances will be attached with my public IP as well as it is attached with my DNS. Okay, so here you can see there are a lot of things. If you see the endpoint, it's very interesting to see there are a lot of things is attached here. This is Amazon provided DNS. See here, you can see here when you either provide your own domain name value or choose default AWS domain name value using the options. And you can see the default, like I said, default AWS domain names can be provided only if you have selected Amazon provided DNS. So I selected Amazon provided DNS. So that's why in this specific region, okay, in specific region, specific availability zones. And moreover, when I go to VPC, when I see the structure of DHCP option sets, a lot of things is going on here. You can see name tag, and we have domain name, and we can provide our own domain name, NTP servers, and we can provide own NetBIOS name servers, everything. So we have something called when it comes to this NTP server, I can say that you can list a 4 NTP server IP address using DHCP option set. And note that, however, this will only accept IP address value and no FQDN, no fully qualified domain name, such as called pool.ntp.org. And then we have NetBIOS name servers. I can say you can list on up to 4 NetBIOS name servers as well. Then we have NetBIOS node type. You can specify the NetBIOS node value, which can be either 1, 2, 4, or 8. AWS recommends that you specify 2 as broadcast and multicast are not currently supported. Many people support it, but it's not supported. So this means you can create and attach only one DHCP option set with a VPC in a time. That's why it is already created and attached. And AWS uses this default DHCP option if you do not specify one explicitly for your VP. So instances either running or newly launched will automatically pick up this DNS and DHCP settings. So there is no need for you to restore or relaunch your existing instances. This is how, but this is how the important things. When we'll come to talk about this last topic about VPC, that what do you mean by VPC limits and cost? I know that so far we have understood about VPC and what is components, and see, VPC is completely free of cost service provided by AWS, and I can say this is free of cost. But however, you do have to pay for EC2 resources that you use. For example, the instances have elastic IP address, EBS volumes, and so on. Also, if you're using VPC to connect your, can say your on-premises data center using a VPN, right? Using a VPN. So what you have to do? And see, if you are using on-premises data center using a VPN option, then you need to pay for the data transfer. You need to pay data transfer over the VPN connection as well. For the VPN connection itself, AWS charges, you know how much? Dollar of 0.05 per VPN connection hour. And I can say that besides the VPC, also have few limits set on there by default. So you can see, for example, when you create a VPC, so you can have maximum 5 VPC per region. You can have maximum 5 VPC per region. Each VPC can have maximum 1 internet gateway as well as 1 virtual private gateway. Also, each VPC has limit of hosting a maximum up to 200 subnets per VPC, and you can increase this limit by supplying requesting to AWS to do so. So this is the default one. So this is how VPC limits and cost we have. I hope after this you understand. So let me move to our next topic is Amazon S3 and Glacier. Because I like to talk on VPC more because of that time consumption. We need to go to next topic, Amazon S3 and Glacier. What is mean by Amazon S3 and Glacier? Most probably everyone knows that Amazon S3, as I already told, we have different types of storages we have seen in our private data center. We have seen block level storage, we have seen file level storages, we have seen SAN storage, NAS storage, iSCSI, NFS, all those types of storages we have seen. We are fed up with guessing capacity, right? Because when I go to Amazon S3, you may think that, oh, it's very simple. It's a very simple console to understand, right? I can say it is very simple console, but it is very powerful. We can see that because Amazon S3 provides developers and IT teams to secure, durable, and highly scalable cloud storage, and Amazon S3 easy to use object storage with simple web services interface that you can use to store any amount of data from anywhere on the web. And this Amazon S3 also allow you to pay only for the storage you actually use, which eliminates the capacity planning and capacity constraints associated with traditional storages. And just remember, this Amazon S3 is a first service introduced by AWS, and it serves as one of the foundational web services. Nearly any application in AWS uses Amazon S3 either directly or indirectly. And you may ask me, what are those services using directly Amazon S3 indirectly? I can say that Amazon S3 can be used as standalone component, and we can see it is highly integrated with other AWS services. For example, Amazon S3 is indirectly accessed by Amazon EMR, Amazon RDS, Amazon DynamoDB, Amazon Redshift for snapshot purposes. All those services and Elastic Block Store, everything we communicate with Amazon S3. And moreover, you can say that because when I go to the Amazon S3, you can see Amazon S3 is a wonderful storage what we have in the concept of a bucket. So let me create one bucket here, bucket. Yeah, this bucket is created. You can see each bucket, okay, it have a separate life cycle policy and storage classes. Sorry. For example, I can say that you see some restrictions we have in bucket. Each AWS account can have only, they can create only 100 buckets, and you cannot have one. You cannot create one bucket inside another bucket. And next one is you cannot install operating system inside this bucket. You cannot run databases inside this bucket. You cannot install and run application in this bucket. So this means this was a restriction. Apart from this, you can able to store any data and retrieve any data inside the bucket. And bucket have different permissions like bucket policy, access control, this cost granted access control instance, and also identity access management. We give the permissions for this bucket to access it. And that's why we have, suppose I'm uploading a small file. So I'm uploading a small file inside this bucket. So what will happen here when you click on this one, you can see this is called metadata. So you can see the last modified, the size, everything is on metadata. You have two types of metadata we have. We have system metadata and we have user metadata. When you see here, inside when I go to this, we can see this this one is called system metadata, and the outer portion of information is called the user metadata. So we have storage classes in Amazon S3 called standard and standard infrequent access and RRS, reduce and redundancy storage. I can say this is the storage classes because see Amazon S3 is the kind of storage that likes frequently of access data, but he never likes infrequent of access data. If any infrequent of access data Amazon S3 detects, then he will forward that information to infrequent access. So within 30 days period of time. So how it is happens? Generally, when I see that because Amazon S3, they, as I told, they offer different range of storage classes designed for various general use cases. And you can see Amazon S3, you can see three formats. One is general purpose, one is infrequent access, and one for archive. Right, so you can see there's we have lifecycle policy that is attached for each and every bucket that we have. What is the lifecycle policy? When you click on this bucket, you can go to management. You can see there is a lifecycle rule where you can set the lifecycle rule for the data to be remain in Amazon S3 how many days, and the infrequency of data have to be moved in how many days to Amazon Glacier. So that is why. So that's why it's Amazon S3 and stick with Amazon Glacier. And this Amazon Glacier, this is another huge amount of vaults they have created inside Amazon Glacier. Amazon Glacier is a wonderful storage for infrequent of storing data, and it have huge amount of storage infrastructure. And another Amazon Glacier, another cloud storage service is the same as Amazon S3, but it is optimized for data achieving long-term backup extremely low cost. And Amazon Glacier is suitable for cold data which is data is rarely accessed, and you can say for retrieval of maybe 1 year, maybe 2 years, maybe 3 hours, or maybe 5 hours. And Amazon Glacier can use both as a storage classes for Amazon S3. And why should we go for Amazon S3? Because we have, as I told, we have traditional storage and block level storages. And we know that traditional storage, what are the traditional storages we have? Traditional storage, suppose we have SAN storage, we have NASA storage, and then we have NASA storage, and then we have iSCSI is a protocol, and then we have CIFS, Common Internet File System, and then we have, I can say, the fiber channel. So this all I can say traditional storage. See, this all storage, you know what's the disadvantage? They have guessing capacity, and they always they are always work closely associated with any servers, and that's why. But Amazon S3 is not this kinds of storage. Amazon S3 is a object storage, something different, and Amazon S3 is a object cloud. I can say cloud object storages, and instead of being closely associated with the server, and Amazon S3 storage is independent of a server and its access to internet. Instead of managing data as a blocks or files using like this as a CSI or NAS, iSCSI. So data is managed as objects using API that's built on HTTP protocol. So that's why. So as I told, Amazon S3 is the one which is based on HTTPS protocol, and HTTPS means what? I can say that because they set, get, put, post like this. So based on that, it will be giving the instruction to in Amazon S3. And just why Amazon S3 is a highly durable, highly scalable object storage, and it provides simple and I can say robust abstraction of file storage and frees you from from worrying about underlying details that it normally has to deal with additional storages. And this, remember, because it has unlimited number of capacity, and single bucket can hold an unlimited number of files. And you also don't need to worry about data durability, replication across multiple zone availability, because MS on S3 is objects are automatically replicated on multiple devices in multiple facilities within a region, and this same with the scalability. So this means if your request rate goes highly, MS on S3 automatically partition buckets to support very high request rates and simultaneously accessed by many clients. That is why this MS on S3 is so powerful storages we have. And next one, I can say that MS on S3 have some high level information about that. So suppose what is a bucket? You can see bucket. Everything is created by a bucket. Bucket is a web folder. I can say it is a flat structure. It does not have any file system, does not have user space, free space. But bucket name can have 63 characters, and as I told, per AWS account can have 100 buckets created by default. One question has interview that I have two buckets. One bucket I have in United States, North Virginia region, another bucket I have created Asia Pacific, Mumbai. Then how to communicate with this? Since AWS is regionless and AWS does not have any availability zone. So how is this means that if I create one bucket in this United States East North Virginia region, so it will automatically replicate to Asia Pacific Mumbai region? Absolutely no. See, I accept that AWS is a regionless. See, even through the namespace for MS on S3 bucket is global, and each MS on S3 is created in specific region that you choose. It lets you control where your data is stored. You can create and use buckets that are located close to particular set of end users, or I can say to reduce the latency, or located in particular region to satisfy data locality. I can say that if you want, if I want to copy the information from, you want to synchronize the information from one bucket in this United States, North Virginia to Asia Pacific Mumbai, you have to click the bucket and you need to go for here management for your properties. You have to go for cross-region replication. When come to cross-region replication, you have to enable the versioning here. Click enable the versioning and go to cross-region replication and create a bucket and select a region, and you can forward the bucket from here to there, and the bucket will be starting synchronizing. So this is something you have to do by yourself, that AWS will not take responsibility of transferring the bucket from one region to next, since it is a regionless. Many people have got a thought, they have the wrong intention in their mind that, oh, I have created one bucket here, automatically it will go to next region. No, we need to something goes across region replication. We need to select a region, and inside that region we have a bucket, and we need to select what storage classes, and then we have to select identity access management role, and then you have to click, and then you have to set that. This is how this cross-region replication works with the help of versioning. And when I come to this one, everything here is known as objects. Initially, see, objects are nothing but storing information MS on S3 bucket. An object can store virtually any kind of data, any format. I can have DLL files, I can store text file, I can store binary file. Basically, here object can range size of 0 bytes to 5 terabyte. Okay, this bucket size is something called, I can say, we can have 0 to 5 terabytes, and single bucket can store unlimited number of objects. And that's why, as I told, this bucket is something that everything is storing the bucket. But AWS refers every data as a concept of a keys. So when I click on this one, suppose I want to access this one in browser. Okay, so this is called device.pem. I copy this URL. Okay, I'm copying. I'm going to browser. I'm going to paste it here. You think that it will give access rights? AWS will block me. That's called access denied. Now, how to access that file? Because since AWS does not support any traditional storage structure, you need to make this as a public. Okay, once you make this public, go here and paste it, that file. You can able to see that file is working here. So this is how, until you make the public, it is a private. The file is private. You cannot access those files outside of AWS Management Console. So this is how AWS works with this called permissions. This is a public and private permissions what we have. So here this link is something called object URL. This is called prefix and delimiters. See, MS on S3 storage for internet, and every MS on S3 object can be addressed by unique URL formed with the web service endpoint and the bucket name. You can see the first of all, you can see this is the S3 is the name of this one, and this is the DNS, okay, and this is the name of the bucket, and this is the name of the file. So this is how AWS, this needs something called object URL. And I can say this AWS MS on S3 is based on REST and SOAP protocol. REST means representation state transfer, and SOAP is simple object access protocol. And MS on S3 have got durability and availability. You know how much of durability? 99.99999% of durability and 99.99% of availability. So this much of storages, this much of scalable, this storages. And that's why AWS has given one more storage that is designed for non-mission critical purposes. That's something called RRS storage. And go to storage classes, select the file and go to storage classes. You can see there's one more storage. This is a non-mission critical application. Like suppose you're using MS on storing an image or thumbnails, because those types of files does not require high level of durability, and we can choose RRS as a low cost storages. And RRS also offers this one 99.99% durability with lower cost when compared to standard infrequent and standard storages. So Amazon S3 also gives you option of creating a static website hosting where is set. So here you can this file. When I go to here management, we have something called properties. When I go to static website hosting, what is mean by static website hosting? So because static website hosting nothing but you can able to upload your files via browser. So that's the thing of the static website hosting, and it is very interesting too. Okay, as a time consume, let me show one demo how to work with static website hosting inside AWS. So that will be gives you a good understanding of how it is works. See, in order to understand about static website hosting, you may be already worked with that, or you may be not. So you may be new to this. And first of all, in order to work with static website hosting, I'm going to configure two text files, and then I'm going to upload that files inside the specific bucket. Okay, so let me do that here. So let me create two files here. So before going to static website hosting, enable it, and you can see use this bucket. It's asking me two things. This one is use this bucket as a host website, and so I have created one bucket here called Zeedup, and inside this one only I'm going to create a static website hosting. Click on that, I can see use this following bucket in the website. Host a website. This is a static website. Okay, there's two types of website. We have dynamic website and static. So we can create a static website inside AWS. It's very easy and very fast and very secure. So let me do that here. Suppose I'm giving index dot let me do txt, and here let me go correct.txt. So let me save it here. Yeah, let's save. So it's a bucket hosting. Now just go there and create two text files. Okay, so let me rename it, and okay, let me just open it, and let me have some. Let me give index.text. That's the file. I think already have that file here. And let me give this as .txt. So open that file and type something that is suitable for you. Suppose I'm typing so I have typed this and save it. And go to error.txt and try to have some things like this. So let me save it this. So I have saved this file. Now go to bucket and upload the two files there. So while you just upload two files, where is that? Go to desktop. We have index.txt. Yeah. Then upload. So let me upload here error.txt. So, so I have uploaded two files. So error.txt and index.txt. So just click on those files, and we need to have we need to do some renames. So what I'm going to do, I'm going to rename them. So let me change it a few things because it's already a text file. So let me save it. Okay, saved. Click on that and rename it and save it. So once you've done that, you have to make this two file as a public. Okay, so you have to give the permission for them to access as a public. So I think that would be down. Yeah. So I'm going to make as a public. Now let me go to my properties and static website hosting and click on this one. And once you click on that one, you can able to see this is written as hello, this is the Zeedup Marathon. It's very simple to this is our created a static website. And some changes you have done inside this and try to run it, you can see you got an error. So this is how this is scalable. This is AWS Amazon is scalable and flexible that you can able to do that. So and if you give the proper link and it will be there. So this is how this is called something called static website hosting that you can create here in AWS. Like this, we have a lot of stuffs we have in Amazon S3. Like you can once you delete the objects, you can recover it. You can have multiple versions of objects inside a single bucket, and you can have transfer acceleration. So compared to that one, so when you go to compare transfer acceleration in Amazon S3, you can see compared to other things, this transfer S3 transfer acceleration is fast and efficient. How it is fast and efficient, you can see this is a normal way of S3, the direct download speed, and after that you can see the speed. We have some speed degradation, maybe the latency. When we are activated S3 accelerated transfer upload speed, it will be fast and efficient. I can say 2 to 3%, maybe 18% of speed will be more faster than normal standard S3 direct upload speed. You can see. So this supports CDN, content delivery networks, and it is more fast than that. And it will show the result how much fast it is compared to normal direct upload speed of Amazon S3. Yeah, so it will be showing here that percentage, and you can 6% faster than that. So we can that's why you can use. You can see this is for all regions. That's available here. So I can't wait for all the regions that you can check. So let me go back to that. And this is called Amazon Transfer Acceleration. So like this is bucket have a lot of advanced features, and that we can use it to for the data storage purposes. Right. So let's go for our next topic is ELB and auto scaling. I hope this one you understand. When it comes to elastic load balancer, this is a good topic because AWS will give you freedom to do your own load balancing. Right, so how to do your own load balancing? So if time consumes, I will be showing you those things. See, actually, if you want to do elastic load balancer, what is mean by elastic load balancer? Basically, elastic load balancer is applied on two EC2 instances. And when I go here, when I go to Amazon S3, and it is applied on two Amazon EC2 instances. When I go to EC2 instances, suppose I'm configuring a web server, right? I'm going to configure a web server between two instances, and I can do the load balances in between them. Okay, so let me do that. So this is my private VPC, and this is my public VPC. Okay. I think these two are my Windows instance, so let me connect it. So I have launched. So I have launched two instances. So we have a elastic load balancer. So here load balancer, we have two types of things. See, elastic load balancer is something that you can apply on EC2 instances, as I told. And elastic load balancer is basically this is preferred option for HTTP based load balancer. There's something called web server. Suppose IIS web server or Apache web servers, that is be very suitable for that. So in case of Linux machine, you can configure this elastic load balancer that is based on IIS, that's based on Apache. In case of Windows machines, you can apply this load balancer for IIS, that's Internet Information Server, and that will be most effective one for us to understand. Because ELB are two types. One is application load balancer and a classic load balancer. So that will be important things to understand. And see, elastic load balancer, we can configure in different ways. So we can configure in a shortcut way, or we can configure in different ways. So, but elastic load balancer is something. This is done when we are working with specific EC2 instance. Suppose my instance is running huge traffic, so I don't have any auto scale, because when we're configuring auto scaling, elastic load balancer will automatically attach with my auto scaling and used to do load balance. See, load balancer is the one that filtering the traffic and giving us required stuffs to that particular instance to run smoothly inside my private system. So let me do that. So suppose I have launched two instances here. So let me give this one as web server 1, and let me change this one as web server 2. Okay, so web server 1. So I have to check the public IP, which is about 52.90. Yeah, so this one is the web server 1, and okay, in case of this is Windows Server 2016. I need to check all this instance has got a public IP. Yes, I got the public IP. Yeah, I got the public IP. So one is running with my, and one is running with my default private VPC. Okay, so I have connected. So let me go there, and so this is running Windows Server 2016. So because configuring a load balancer, so most probably I wish to go for IIS. So that will be the comfortable one for us, because see, you can apply load balancer almost in for anything. So like you can create for databases. Also, you can go for web server, anything that is possible. So, but main things is if you go for any web server, that will be the suitable example for you to do that. So let me go to server manager. So for that, you should have a basic knowledge of Windows servers. So I'm going to add IIS, Internet Information Server. Let me do that. Because it is running in T2.micro, so that will be slow because it has 1 GB RAM and one processor. So let me add a web server. Okay, go for IIS. Then install it. Okay, so just do this for same for this machine. Now click on that and install it here. Go to next. So this is interesting part that we can apply load balancers for web servers because we know the huge amount of traffic will hit for web servers. .1 is restart. Okay, so let me check it here. It is already installed. Close it. Go to manage, go to tools, and we have a IIS server. See, in order to check whether my IIS is running properly, so go to any browser, maybe Google Chrome, Mozilla Firefox, or Internet Explorer, and you can check whether it is running properly or not. So let me do that. Okay, so let's just type this IP 127.0.0.1, and once you execute this, and show that this is running properly. So this web server is running properly. Okay, after that, get inside this IIS. So because you maybe have some experience that you have integrated with IIS, or maybe you are new to this one. Because once you integrated with IIS, you can understand about how this elastic load balancer is actually, because it is because each web server can do their own load balancers, right? So if you want to do load balancer in the cloud, that's something very interesting to do that. So go to here and go to sites. This is a default website. Click on this one and go to manage website and go to advanced settings. So I go for here. So I click on browse, it will take you the browser. So it will take you the default page where you can able to see that one. I think it's already there. Yeah, so it will be show this site. So as I already typed localhost 127.0.0.1. So that is this is Windows Server 2016 where you can able to launch it. And since we have, because most of the time we feel that Windows Server 2012 is the best for configuring the web server compared to Windows Server 2016. So in this case, in Windows Server 2016, that we have in pub, that's a folder that we have stored here. So this is the main folder that what we have when you're going to launch this one, and this you can do edit it, where you can go to IIS start, go to open with, or go to notepad where you can see the script that this whole thing is there. So where you can add your own style. Let me check that. So let's save it. Go to browser. Just check whether this is reflected there. Yeah, so yeah, so it is reflected because so this is how I have edited some site there. So okay, so let me check whether it is reflected here also. So by copying the endpoint here and go to some browser and just paste it here because it should be communicated with DNS in order to paste it. Let me check whether I have selected the right instance. This IP is 52.90.249. Yeah, this one. So it really should reflect that in the browser. So like this. So what I have done here in Internet Explorer, and this is Zeedup Marathon. So what I have to do, I need to go for another instance, and also I need to set up that IES. After finishing that, what I'm going to do now, I'm going to go for Elastic Load Balancer. Okay, so after doing Elastic Load Balancer, create a load balancer, go to Classic Load Balancer, and I'm going to give some name AWS and which VPC you want to launch. I can throw it the default VPC I'm going to launch, and this is at HTTP. Otherwise, we can add HTTPS. That's secure, port number 80. And this is asking select existing security groups. So let me select this one and click on security groups. And suppose you have existing security means you should ask that. Otherwise, go to back and give the name and add it and give the default one. So here you can see asking the health checks to click. Now it's asking add the EC2 instances. So it's showing only one because I think another instance that we have not configured inside that. So let me do that. So let me check whether they are running in same. Okay, this is US list 1C. And I go to EC2. There's a problem. So it is running a different availability zone. That's why it is not detected there. So I need to launch a web server in same availability zone. So then only I can able to connect it. No problem. So what you have to do there? I will show the total process. So when I go to load balancer, click on that, continue, and click add. Let's default one and check. So this will be selected. Now add tags. Web server of 2. Again, create it. Okay. So after we get this one, so you can see you can add more instances inside. So you can edit instance and you can add more instances later. And this one is given endpoint, right? This is a DNS endpoint for load balancer. After you have configured 2 instances IES, right? So one instance running Internet Information Server, another also running Internet Information Server. So if you copy the individual endpoint to the browser, so they show that their own running website, web server information. Once you do the load balance, when you copy this endpoint, right? When you copy and paste this endpoint into the browser, then you will do the load balance between 2 instances. So if first time which instance has got less traffic, that instance will get the first priority. Which will go second and more traffic, that instance will get the second priority. So like this, that's why this elastic load balancer is most effective one when it comes to HTTP based, when it comes to web server based, databases based instances, EC2 instances. Traffic is balanced between them. So that's why this elastic load balancer. Next topic is auto scaling. Let me finish it that also. See what is meant by auto scaling. First, let I give. First, you understand what is the benefit and what's the main use of auto scaling. We know that auto scaling is a major concept we have in cloud computing. So in AWS, no person will be working inside AWS without knowing about auto scaling. We have seen different types of scalings, right? We have seen uh, about we have Amazon CloudWatch, and we can say that we have alarms we can set for that. But auto scaling is something there where we can launch an instance inside and make use of that. So let me launch an instance. So suppose I'm launching this one, Windows Server 2016, and use a name. And suppose I have treated IAM root, can able to select it and you can enable this one, add storages. See, instead of creating like this, you can able to go here, EC2, and try to launch instance. I have Windows Server 2016 and click, and let me launch it auto scaling group. So here it will take you to here and asking me the name and click storages, so that it will be storage, and I have given the security groups and create launch configuration with the particular key pair. Yeah, so now it's asking the group name, so this is typing a number of instances. I need 5 instances. You can see asking, and you can see here which VPC I need as a default VPC. Suppose here you can select your own VPC that you do the auto scaling, and which subnets you want. I am selecting for US61C, and you can create more subnets here, and you can select 1D or 1F, all those things. So that scaling policy. So this is the important page that you keep this group as initial size and use auto or use scaling policy to adjust the capacity of this group. We go to scaling policy. So you can see scale between 5 and 5 instances. So this will be the minimum maximum size of your group that you have. And you can see based on the utilizations of your CPU, based on the utilizations of networks, you can able to have a scale it. So suppose I keep the initial size for this. He has nothing for that. So what I have to going to do, I'm going to have scale between 6 and 6, 6 and 6 or 6 and 5, and I can keep 6 and 7 or 6. So you can use auto scale simple scaling policy. You can increase the group size and by adding and set to particular thing, or we can add by number of percentage in say. We can decrease the group size and we can set alarm for that. And alarm is something important for to set. See, when configuring auto scaling, elastic load balancers automatically fit here. Alarms are automatically fit here. Amazon CloudWatch automatically stick here. So now all things are coming inside for those instances. So I can create more alarm, and I can set alarm for CPU utilization less than 40%, or less than greater than, or I can say less than equal to, greater than equal to. Based on that, and AWS will send a notification for me via Amazon SMS. I can create a topic and give your mail ID. He will be sending those notifications. Instead of without configuring auto scaling, also you can set alarms for that particular instance to have it. And if this is increase the group and decreases the group. So when you can see set to or all. So if you're giving a specific condition here based on that, then AWS will make use of those auto scaling group based on that. Suppose you are not familiar with this, go to this keep the initial group size, and now you can go for this configure notification. So the best things is this. So based on the scaling between 2 instances, and see, this will be the minimum maximum group of your size, and see, this minimum group size must not be greater than starting number of instances. So let me give 2, and instance group size. So you can set alarm for what purposes you are setting alarm, and for what purpose you are setting the decrease group size. So you can configure this one based on that, and you can create a simple scaling policy, and with a few steps, and we can add steps. This is some conditions where you can set that, and this is how we create the number of things what we have. And scaling between, I'm going to give like 2 and 2 instances, and you can see the minimum size cannot be larger than maximum size. So let me give, suppose I have give 5 of scaling of 5. So if we give this one 5 F5, and then I can add notification, which one launched, terminate, failed to instance. So everything will be added here, and send notification to where? DynamoDB or keeping thread topic, send your mail where you can give that existing topic. So config in this and this add keys. So you can give your name and value. So this is auto scaling. So now treat it, and thus you can treat it and close. So you can see this auto scaling. This F5, name of 5, maximum 5, and hold down. You can see here these things are running, and you can see not yet in services this activity. So when I go to instances, yeah, so you can see this all things started, and now this all things under auto scaling. So auto scaling is effective because auto scaling configuration and deployment, once completed, you're ready to go ahead with verify its validity, and you can check the instances. And when I click on that instances, I can see status check. And once you status check, additional resources can be then monitoring things, and you can see there. And once you've done that, you can go auto scaling groups and go to actions. You can edit and delete it at any time, and so you have scaling. You can attach. You can see the scaling policy what I done, and the number of instances running here are all healthy, and you can see the life cycle. And you can tune that. You can do those tasks like in service, printing, terminated, standby, entering standby, and instance. Every time the instance health will be checked frequently and appropriately, and that's why this auto scaling. Because he maintained everything, what are the things we need, he will be adding there in instance, and what are things we don't need, he will be filtering there. So this is how auto scaling process totally works for us. And we have more, great depth of where to go auto scaling, and these things we can be continuing when we started our AWS, classes for. In that time, we'll be teaching, we'll be going through more depth of auto scaling and how we discuss the pros and cons of this one. So let me add one more thing. Is identity access management, MS on 53. Okay, so when I talk about the identity access management, this is the console where we are understanding everything about just like Active Directory or how we have in on-premises data center. What is use of Active Directory? Creating users and giving them policies, giving them access restrictions and all those things. So that's things we have. The same things we are going to work in identity access management. So in identity access management is a console also comes under regionless. It does not come. That's why it has a global identity with us. So. And also we have to understand this identity and access management is a where you can manage 5,000 users. You can create here, and you can able to launch it here. So via identity access management, you can create users groups, and you can manage account settings, and you can give a high-level application support called multi-factor security, multi-factor authentication, X.509 certification, as well as you can assign the permissions for users and groups. So that's why this auto scaling. And basically, this identity and access management. Basically, this identity access management used in different conditions and different purposes. For example, when we go for this one about this identity and access management, most of the identity access management has proved security. And just remember, AWS does not ask you any expense for us when we're working with identity and access management. Because identity access management, this console is absolutely free console for us, and you can able to use it for accessing the AWS account purposes. And moreover, when we understand that how identity and access management integrate with us, and how to create identity access management groups, and how to work with, how to give a security policy. So inside identity access management for particular user. And in order to do it, first we need to understand, because we need to create a basic identity access management user, and then we have to put him on track. So that's why. So how to create an IAM user? So basically, we need to understand how to create IAM user inside AWS, and we need to make him active one. When I come to go to users, you can see you can add user, and really asking you about the username. And next things, let me give one username here. So before going create a username, it is better to create a group in identity and access management. So let me create groups. Okay, create a new groups. So let me create one groups, and I can give any name to the particular group. Let me give administrator. Okay, so once I give the administrators in that, and we go for next step. So yeah, so here we can see already I have given. So let me give IAM, identity and access management. Now you can see. Let me go to back groups. Right. So yeah. So here I need to give this IAM full access. So once I give that one, click next. I can see this will be creating a group for me. So the group is created called administrators. Now go to users and click add user and put in that user inside the group. So give name administrator. That's so let me create a user administrator. And give him two access, programmatic access and giving him AWS management console access. Okay, so now there's time for password. So next, no need to give a password for him. So I'm going to give next. So you can see the group that I created here. It is administrators. Click on that and go to next step review. Okay, so now I have it's time for me to go for next one. You can see manage group, and I name user change password. Now create user, and it's creating a user. So it takes some time. Yeah, I got it here. You can see I got this one administrator and the password, show access key, and secret access key. So now I can download a CSV file. So AWS will give me that particular user password. So this link will be there for the particular user to log in to the console. So go back to services. When I go to identity and access management. So when I go here, you can see this should be there, and copy this and go there and paste it. And we'll be asking you the username password. Yeah, so you can see username. So obviously, I need to sign out this one. So you already logged off because I didn't have user can able to get into that my account. And obviously, you can see the username is what I gave there, administrator, and the password is the one which is the I have to download the password from that key. And since I have not downloaded the CSV file, so you need to type the username and password. Once you sign in, this user will get a separate AWS management console, and I need to replace my old password to a new password. So like this, you can able to share the particular your AWS accounts with other user, and you can get the identity access inside this one. Okay, so if you want to go back to root user, click on this sign on root user credentials and just log on back. See, actually, so I created one user and one group and one role. Everything is there. So that's we can able to create more users. You can manage more users, more groups here at the access management. And just remember, please don't delete your root access. Okay, this is the one which is unrecoverable. So most people will do that. They will go delete the root access and they can able to get it back. They think it is not possible. So don't delete user root access and keep it there. So we have a lot of things about identity access management, creating users, groups, giving permission, giving them multi-factor authentication, giving them a lot of stuff is the one which is something insufficient of time, we cannot cover those things. So sufficiently, we will be going through the classes about the AWS solution architecture. So then it is better for us to understand more depth of auto scaling and then identity access management and Amazon S3 and those kinds of stuffs. And this is MS Route 53. This is a last topic, so that will be because as we know, the MS Route 53 is you know what is the port number of DNS is 53, the same as that we have MS Route 53. When you go to Amazon, this one, this MS Route 53 is also a regionless services because he is the global vendor for DNS namespaces. You can see this also regionless, same as S3 and identity access management. And this is he is a global domain registrator for us in AWS. So he used to maintain DNS, traffic management, monitoring, and do domain registration, and everything he used to do that. So that's why Amazon Route 53 is the one. Is a domain registrator for us, and where you can create a private DNS and public DNS with low cost. So when it comes to DNS management and create hosted zones, there are two types of hosted zones we have: public and private hosted zones. And come to Amazon Route 53. You not understand the complete process of Amazon Route 53. You need to understand about the process of DNS records. We have different types of DNS, 26 types of DNS records we have. So based on the DNS records we have. So suppose I'm giving Zeedup.com, and when I try to create it here, you can see the set of records I have created called name server, startup authority, and you can see all types of record types we have. So you need to make use of these types of records inside AWS, and you can test this record. And once you test these records, you can see with the resolver IP address. So my AWS will communicate with CDNs, content delivery network. So that is called edge locations, and he will use to integrate with a particular domain with the particular record types. See, moreover, Amazon Route 53 is the one is a global domain registrator for AWS, and when particular instance is getting endpoint, who generate the endpoint? If you think Amazon Route 53 is the one who generate the endpoint for the particular instances that you're launching here. So this endpoint, and just remember, Amazon Route 53 is the one that can be integrated with hosted zones and traffic management, and you can see he can register the domains with low cost. You can register your domain and you can check whether it is available or not, compared to the private domains that you registered in GoDaddy.com or any other kinds of stuffs. So these things, because Amazon Route 53, I can communicate with my EC2 instances. I can be, because this Amazon Route 53 is a huge traffic management tool as a component, and it's very effective when come to managing huge amount of DNS traffics we have inside AWS network. So that's why, and this also this is a regionless service. So that's why you can create a domain, you can manage your traffic, as well as you can communicate two types of DNS, private and public. So moreover, as we talk about Amazon Route 53, it will take more large type of route to integrate him. So that's why when it comes to this complete classes for AWS, so we'll be teaching you that how Amazon Route 53 is integrated with auto scaling, ELB, as well as Amazon EC2 and also Amazon VPC. So this is how today we discuss about VPC and Amazon S3 in place here, ELB, auto scaling, IAM, and Route 53. I hope you understand that. So that's why we are running short period of time. That's why I have not elaborately explained about ELB auto scaling, but I think of what the things I explained, I think you understand. So yes, guys, it's time for me to. This is question answer session. You can start asking questions in chat messages. So first question I got: how to configure stateless and stateful firewall? Actually, as I told, stateless and stateful is nothing but it's a security groups, and we come to stateful is the one which is something I can say that stateless is a firewall that's called that's network access control list. You can configure in VPC. Okay, so you have to give inbound and outbound traffic. So, but stateless firewall is best because they support both scenarios of that. And come to the next, how to trace packet loss, security attacks, logs, and packet sniffers. Actually, I'm sorry to say that AWS will give only one tool for you to do those things called Amazon CloudWatch. And here we have, and this all the management tools what we have, and they used to manage all the traffics inside. They used to not even CloudWatch, Amazon Cloud Trial, Amazon Cloud Formation, and Trusted Advisor. So these things will gives you the complete information about those things. How to back up or restore network settings, routing DHCP, DHCP. See, actually, the thing is, our on-premises DHCP service is something there, something different, and the DHCP server that is running in Amazon VPC is something different. Okay, so don't break your head on these both things, because on-premises data center VPC, sorry, on data center network is the one we are physically creating the DHCP server, and in case of lost, we have a jetpack, and we are going to accessing that. But in case of Amazon-based DHCP, is not like that. So because everything is centralized and everything is there. So what we have to do that, what AWS will automatically do those things about that if I lost the route tables and DHCP scopes. But in case you are creating by yourself, then you can able to do that. Okay, in third, in resource groups user screen, we have option to user password and how to. Okay, so in the source groups user string, we have show option to show user password and how to secure manage user accounts. Uh, sorry, so in resource groups, see those users comes into resource groups, those have already username password, so they can able to view their own passwords. It's not something like this. They can view the password, but not something they are logging inside that. But someone have your access ID key and share access key, then they can able to do that. By even if you're not logged on your system properly, they can able to crack you. So in case of this types of things, when show user password, but it's showing user password only I'm logging into that. Otherwise, they will not show those things for third-party users. And yeah, so okay. So next question is limitation of instance and auto scaling. I can say that the answer for this question, yes, we have some limitations of instances and auto scaling because AWS is not given fully that you can have any unlimited. I can say for AWS accounts can have 20 instances. Okay, so that's the limitation. So if you go beyond that 250 instances, something like this, yeah. So we have some limitations of instances based on that, because based on the cost and based on the support, developer support, basic support, enterprise support, what support you have taken while creating the AWS account. So based on that, that limitation of instances will be supported. And next question is how do I choose transfer acceleration Amazon CloudFront portal for CSV? Amazon transfer acceleration is something, and you can do that. So you can choose between transfer, because transfer acceleration is nothing but you reducing the latency and putting the more fast, more performance on those transfers of information. So Amazon CloudFront put and post, yeah, you are talking about HTTP. It is you can choose between that. So see, in order to understand CloudFront, you need to completely understand about these things. So you're talking about this CloudFront, yes, because you have to understand about completely about the CDN, content delivery network, about the nature location. So CloudFront is the one which gives the more performance, acceleration speed. We come to as you told, put and post. So if you transfer the transfer acceleration and Amazon CloudFront post, put and post has to be done something by CDN, content delivery network, and that has to be done in various. Suppose you are going to communicate with different regions, your office has been connected in different locations like India or United States or Australia. So you can go for that Amazon CloudFront and you can do the transfer acceleration. That something based on the extra expenses. Next question is how to check the bandwidth in server AWS, and you have hosted multiple websites. Need to check every site's consume bandwidth tools available inside. Sorry, see, actually the bandwidth consideration and all in AWS is the one, those types of tools we have only the management tools. Okay, so here using these tools only you can satisfy yourself the checking availability of this one. We want to check every bandwidth consuming available tools. Go to EC2 instance, inside EC2 instance, and download some tools and you can check it. But in AWS management console they have not given anything to check the bandwidth in AWS. They have given only the network performance for the particular EC2 instance to launch. So that's why when I go to EC2 instance, when you click launch instances, and when you're selecting the particular instance type, you can see they given the network performance. This only the measurement right now what we have. So they have already given the particular bandwidth speed for the particular instance to manage the traffic. So apart from that, there is no thing. And apart from that, management tools are there. Based on that only we can able to do that. We can able to check that. And next, it is work with edge location. See, edge location, as I told, is the one that is this called. This comes under content delivery network, and edge location is the one who increase the speed of execution of the application. That's something that comes under, because based on the speed, I can say that only this option is available. Yes, any more questions that you have, so you can ask me at this point. So next, after this, I'm going to explain a little bit about the AWS exam that you can able to take it. So how to take AWS exam, because the best preparation for exam, for certification exams is a practical experience. Okay, so you guys maybe have practical, or maybe you are fresher, or maybe you are intermediate level, or maybe some advanced level. Actually, I don't know that stuff, but if preparing for AWS certification, you need to have a great practical experience. And so we recommended that you should have maybe 3 months or maybe 1 year of hands-on experience on AWS. So that's why. So if those guys are coming based on that experience, so and they can able to go for many cloud-based examinations and all. So recommended path. Okay, what is the recommended path for taking exam? So I will tell you here recommended path for taking exam. So first recommended path is take an AWS training class. Okay, so you have to take an AWS training class. And second is we have to review during the training. You have to review the exam guide and sample questions. And third one, practice with self labs, that what you have, what I give, and based on exam preparation first. And fourth one, you have to study AWS white papers. Okay, so that will be but that will be the good fundamental for you to go for, rather than go for some ebooks, you can go for study AWS white paper. So because AWS white paper, because if you want more depth technical understanding, you can, because the AWS has released different white papers, and because AWS has team that's called independent analytics and AWS partners joined together, and they have given this as AWS as a white papers. So this is the recommended practice for taking AWS exam. If you follow this rule, first take AWS training class, then review an exam sample questions, and practice hard with self-placed labs, and study AWS white paper side by side along with the training. When you do those things, you will be getting 100% knowledge about AWS networks, and you can crack AWS examination. So this is the recommended path that I suggest you to take AWS exam. And surely after 4 steps, as I told, you will be cracking AWS exam, and you will be happy with your hard work. So this is the how you teach. This is the recommended path that I just explained to you. Thank you so much, guys, for your availability within these 4 days of AWS Zeedup Marathon, and I just appreciated your time that you have spent with us, and I hope you understand all the concepts what we have explained to you. step by step and what are things. Well, I think you have your doubts are clear. So within these 4 classes of AWS Zeedup Marathon. So I hope what is a total what is a program to this event. I think you hope you enjoyed, and I think you are getting those videos also across the link. Okay, so that's why the YouTube's and maybe Google Drive link inside that one, and you are accessing those videos. So for more information of any queries, or you have any technique, you want any technical assistance, so please contact my colleague Dinesh for more assistance. And moreover, so once again, thank you so much for joining this session. And I hope this session is gone very wonderfully for you, and all these 4 days. And moreover, so if you have any personal doubts, or you want, so we will be providing you extra documentation for this also, that you can that you will be getting shortly. So, so okay, let I ask, let I take one more question. Just wanted to know real-time use of HTTP server AWS. What if you connectivity web server? Yeah, this is actually AWS is a live network. Okay, so what are things you need to have? You can able to go here, and you can able to get the real-time HTTP server. If see connectivity issues, I can say if from your side any connectivity issue there, then you do take care. But AWS does not have right now. It does not have connectivity issue. If it's there, they will solve it. The question is how do instance without public IP? And no, without public IP we cannot access the instance with the internet. And next is thank you so much for everyone, and I think thank you for your appreciation, and thank you so much for enjoying all those days, and hope we see in future. And once again, happy Independence Day, great day, and I'm doing best of luck for for all those days that's coming for you. And thank you so much, guys. Again, see you in future. Take care.
Thank you
Goodbye.
so much, guys.